Hello friends, I welcome you all to this lecture of fluid mechanics. Today I will be discussing with you the stability of floating bodies. So first thing first is, when will a body float in water, let us say, or any fluid? The body will float when the density of that particular body is lower than the density of the fluid on which that particular body is kept. Okay, now in case of submerged bodies, which you have learned in the last lesson, that the submerged bodies, when they are submerged, that means totally immersed in the fluid, then if you disturb the body, then what will happen? The relative position of the volume displaced, okay, will not be going to change. Means the center of volume displaced will not be going to change if you tilt that or if you rotate it. But this is the difference, that in floating bodies, when you tilt it, when some disturbance is given to the body, what happens? The relative location of the buoyancy point gets shifted, and due to that the understanding or the feeling of the stability changes. So what I mean by that, so let me explain this with the help of a figure. Consider that this is free surface of liquid. Okay, now you have a boat or a ship, let us say this is the one. Okay, so for the time being, assume that this is the center of gravity and this is the center of buoyancy. Okay, from here W will be acting, from here buoyancy force will be acting. Now what will happen if you disturb this body? So if you disturb this body like this, then if you look very closely, okay, this was the original line. This was the original line of flotation. That means the line which is aligned with the free surface, so at which it is floating actually. So this was the original line of flotation. So the moment you tilt this body in this particular direction, you will be able to see that this much volume has moved out of the fluid and this much volume has moved into the fluid. Okay, due to which previously about this line of symmetry there was equal volume distributed on both the sides, but the moment the ship or the boat get disturbed or twisted or tilted in this way, the relative position of the volume has been shifted. That means with respect to this particular line, symmetry line, more volume is now onto the right side than in comparison to left side. And if you assume that there is no relative displacement of the objects in the boat, that means the mass has not been shifted, then buoyancy force will not be changing, that will be acting here only. Weight will not be shifted, it will be acting here only. But what will happen? This was buoyancy initially, center of buoyancy initially. But what is center of buoyancy? Center of buoyancy is the centroid of the displaced volume. Okay, so now what will happen, as the volume has been shifted towards right, so this will also shift towards right. Okay, the buoyancy point will now get shifted towards right because of more volume which is on the right side, displaced, more volume displacement on the right side. And from here, from this point now, this buoyancy force will pass. Okay, now previously and now, if you look very closely, if I extend this line and the point at which this line intersect the line of symmetry, if you look very closely, if I draw this line here, okay, for your understanding, this is G from where W is acting, and this is, let us call it as M. This is M from where now buoyancy force is passing. Then you will be able to appreciate the fact these two forces, as this is floating, so W will be equal to FB only and unconstrained. So W will be equal to FB, and they are forming a couple which will try to rotate in this direction. That means opposite. So a restoring couple is coming into picture. Okay, so whenever an object is floating, so the relative location of W and G are important, but the thing which is most important is the position of this point M. So if the point M is above G, then a restoring couple will come into picture and will bring the boat to its original equilibrium condition. That means this boat will be stable. Okay, so the stability criteria of floating bodies is basically this point M, and this is what is called as metacenter. So if the metacenter is above G, if the situation is like that, if the metacenter is above G, then this will be called as stable equilibrium condition. If the metacenter is below G, if the metacenter is below G, then this will be unstable. Why? Because let us say that this was the symmetry line, this was this was your G, and metacenter happened to cross this line below G, then this is W and this is FB, and now they will be forming what type of couple? They will be forming a clockwise couple, that is overturning couple. So for original disturbance given clockwise, this is clockwise, means it will sink the boat, and hence this is unstable. So when metacenter is below center of gravity, that is unstable condition, and when metacenter happens to coincide with the center of gravity for these small disturbances, then this is called as neutral buoyancy condition or neutral equilibrium condition. That means whatsoever the condition now taken up by the boat, it will remain there, it will not be going to change at all. Hence, for stability of floating bodies, the important thing is the relative position where this M is lying, and this distance between M and B, this BM is called as metacentric radius, and the distance between G and M is called as metacentric height. Okay, so by saying that M is above G, I mean if this metacentric height is positive, if this is positive, then this is stable. If this metacentric height is less, then this is unstable, and if this metacentric height comes out to be 0, that means the M coincide at G, then this is neutral buoyancy or neutral equilibrium condition. Now you must be able to appreciate the fact that this metacenter is nothing but the geometric criteria or geometric stability of the body. Okay, M doesn't exist as such, but this is a geometrical criteria to tell whether the particular floating object will be in stable equilibrium or not. So whenever you have a body which is floating on the water or any fluid, then for stability of that particular body, the metacenter should lie above center of gravity, or the metacentric radius, which is the distance between center of gravity and metacenter, should be a positive value. Otherwise it will be unstable and the object will sink for small disturbances. So in the next video or in the next lecture, I will be telling you that how to evaluate this geometrical criteria of metacentric height, and when a ship or boat will be more stable in what condition, in rolling or in pitching, so that we can emphasize more on the stability and design the boat accordingly so that it will not sink in that particular condition for normal disturbances. Okay, so in this lecture till this point only, if you like my video, then please do like, share and subscribe. Thank you very much. Take care.